Continuing on with the shell method, let's take a look at a second example where this time we're going to revolve around the x-axis instead. So here I'm given 3 different curves that bound my region R, my 2-dimensional region, and I'm going to rotate that region around the x-axis. So we've got the line y equals 4 minus x, the sloped line I should say. Here we have a horizontal line y equals 2, and here we have a vertical line x equals 0, which remember is just the y-axis. So of course we'll want to take a look at the 2-dimensional graph of all of this. Alright, so here I have a graph. You can see we have the line y equals 4 minus x right here. Here is the line y equals 2, and then of course we have the y-axis. And so those 3 lines together form a triangle. We're going to take that triangle and we're going to revolve it around the x-axis, and we're going to use the shell method to find the volume of that resulting solid. Whoops. Alright, now remember shell method is backwards, or it seems backwards anyway, where if we're revolving around the x-axis, it actually means that we're integrating with respect to y. So, because of that, I need to take each of my functions and rewrite them in terms of y rather than in terms of x. So think about in this first function, how am I going to isolate x? Well, I'm going to get x alone by adding it over to the other side and then subtracting y. So x equals 4 minus y is one of my functions. And then the other function is the function x equals 0. Okay, so you can't take this one right here and you can't put it as an x, you can't write it as an x equals expression. It's not possible. So that's why we're using this one and this one. And it also makes sense here, since we're revolving around the x-axis, that we want our functions to be these two. Alright, let's set up an integral. Hopefully we can make sense of where all of this comes from. So 2 pi r is the circumference of the cylinder, and here's my 2 pi, which I already pulled out, and my r in this case is y, since we're integrating with respect to y. Here's the height of my cylinder at any point on the interval from a to b, or in this case really from c to d, since we're integrating with respect to y. But I'm going to take 4 minus y, and I'm going to subtract 0, and that'll give me the height. And then 2 and 4 are the intersection points between these 2 lines. So you can see here at 2 and here at 4, that's where the line y equals 4 minus x intersects with the y-axis. So that's where I get those limits of integration from. In order to integrate 4 minus y minus 0, the minus 0 doesn't do anything, so that will go away. And then you'll also want to distribute your y. So we get 4y minus y squared. And don't forget, this is with respect to y. Great time for you to try that integration, and pause the video and come back and check your answer. Okay, if you're back to check your answer, we should have gotten 32 pi over 3. So if you were able to get there, fantastic. You can probably stop now and move along to your homework. Great job. If you need a little bit more explanation, then stay with me. So remember that we are using the power rule to integrate each of these terms. For 4y, we're going to raise the power to 2, y squared, and divide it by 2. So that simplifies to 2y squared. Over here we're going to add 1 to get y cubed and divide it by 3. We can't forget our 2 pi that we pulled out. Let's plug 4 into all of that. So we're going to plug 4 in. 4 squared is 16. 16 times 2 is 32. And then over here 4 cubed is 64, and 64 divided by 3 is a fraction. So now we've got these two expressions. that we need to combine getting a common denominator, and you can see that I did that down here. Okay. Checking my math really quickly. Let's just hope that this 32/3 represents what happens when I plug in 4, and then this over here represents what happens when I plug in 2. I'm hoping I didn't make a mistake on that. If I did, let's make sure that we clarify that in our discussion this week, and make sure that you guys are getting the same thing. Anyway, once we do that, we've already got a common denominator we can combine and get that answer. Alright, so that's it for videos this week. We've got washer, disk, and shell methods. We also have the general slicing method, which is a little bit less useful. But either way, we've learned how to find the volume of solids created by rotating two-dimensional figures about different axes.